Okay, so just a quick heads up. I'm sending you these just because it's helping reinforce this in my head. You are under no obligation to watch any of these. I just think it's pretty helpful for me to explain this to someone. So for this question, it's kind of trickier than the last few. It says Ben agrees to a $60,000 loan for 30 years. The loan has an annual effective interest rate of 5%. The loan is repaid with annual payments consisting of equal principal payments plus interest on the loan balance. All payments are made at the end of the year. After the 16th payment, Ben decides to completely pay off this loan with two payments. The first payment is $20,000 paid immediately. The second payment will be made in 5 years. Calculate the amount of the second payment. So the first thing to note is that the loan is repaid with annual payments consisting of equal principal payments. So what that means is you're just going to take the total principal and you're going to divide that amongst the number of payments. Now, when this repayment plan was initially created, it was for a term of 30 years with annual payments. So you would take that $60,000 divided by 30, and that's going to give you an annual payment of $2,000 towards the principal. Now, what you would do after that is it says you're going to also pay the interest on the loan balance. So the first year, the loan balance is $60,000. So the interest would be the 5% times the $60,000, which is going to give you $3,000. Then you go forward to the next year. We repeat this process, but the principal has been reduced by $2,000. So you would take the $60,000 minus $2,000 times the 0.05 or times 5%, which is going to equal $2,900. You repeat this process, and each successive payment decreases by $100. And it says you do this because you make 16 payments. So you repeat this process for 16 years. At 16 years, he decides to pay off this thing much quicker. So he pays it off with an immediate payment of $20,000. And then 5 years later, he pays off the remaining balance, which we don't know. So we can condense this all into a cleaner looking time diagram. You add these total payments to get a total payment of $5,000. Add these two to get $4,900. Add these two to get $4,800, etc., until we get to year 16, which is a payment of $3,500. In addition to that, we have the $20,000 extra payment, and then 5 years later, we have the payment of X. Now we bring this all to time 0 because we know that at time 0, this must all be equal to $60,000. And so right from year 0 to 16, we have a decreasing annuity. It starts out at $5,000 and decreases $100 every year. So this is kind of my short notation for how I input this into my calculator because it's much quicker than doing it by hand. And we get the present value of this decreasing annuity is equal to a value, and I stored that here. And I discounted this $20,000 back to time 0. So multiply it by the discount factor, raised to 16 years. Brings it back here. I stored that value in 1. And then I take this X value, discount it 21 years, bringing it to time 0. And I know the discount factor here is equal to this stored value. I add these two together, and I take $60,000, I subtract that sum, and then divide by this stored value, which gives us the result X is equal to about $10,200, which is the final answer.